Hello everyone! Today we're going to be going over problem number 206, reverse linked list. The problem description is as follows. Given the head of a singly linked list, reverse the list and return the reversed list. Now for example 1, we see a very simple linked list, 1, 2, 3, 4, 5, and in the answer we see that it is 5, 4, 3, 2, 1. So the problem is very simple, but I want to make sure that the solutions are very clear, because this is an important problem. So there are two main solutions. The first is the iterative solution, and the second is the recursive solution. The iterative solution requires that you keep track of a previous variable. You're going to use the previous variable to flip the arrows in the linked list. So let me show you an example. If we had the original 1, 2, 3, 4, 5 list, what we would do is go to 2, and then realize that we've been keeping a previous variable, which points to 1, and we're going to use that to say that the next pointer of 2.next, should point to the previous variable, which is 1, which is essentially flipping this arrow, such that 2 now points to 1. And then we're going to go over to 3, and we're going to do the same thing. 3.next should point to the previous of 3, which is 2. Which means that we are now flipping the arrow from this to this. 3.next is now 2. And then we're going to go to 4, and we're going to do the exact same thing. 4.next should be pointing to the previous of 4, which is 3. So now we're going to take that arrow and flip it so that it's like this. Then we go to 5. This is our last one. We're going to say 5.next should be pointing to the previous of 5, which is 4, which means that we're taking this arrow and flipping it so that 5 now points to 4. So overall, the implementation is pretty simple to understand. We're literally going through the linked list from the beginning to the end, and we're using a previous variable to help us keep track of what we saw in the past, and using that to flip the arrows we see along the way. So that's the iterative solution. Let's go over the recursive solution. The solution is a little harder to understand, so I'm going to go over it piece by piece. The first thing you have to understand is that we have to go through this linked list from the beginning all the way to the end. So the recursive solution requires us to go from 1 to 2 to 3 to 4 and then to 5. And then once we reach 5, we have to ask ourselves, what is the reverse of 5? Well, it's simply 5, right? There's only one element there. So that can be considered the base case of our recursive solution. Now, once we finish the base case, we go backwards, right? Recursion is nothing more than going all the way down to the base case and then jumping backwards until you get all the way to the beginning again. So if we find ourselves back at 4, and we now know that the reverse of 5 is 5, how are we going to continue? Now, the most important thing to realize here is how we can flip this arrow so that it becomes this arrow. The way we can do that is saying the following, is to do the following. We say 4.next should be 4. You see how that works? We're saying that 4.next, which is 5, .next should be ourselves. Essentially flipping this arrow so that, or rather flipping this arrow so that it becomes this arrow. So that's a very simple idea that we're going to keep doing over and over again. So let's say we already flipped this arrow, which means we are now back to 3. And at 3, we're going to do the same thing. 3.next should be 3, which essentially means we've made the arrow become this. We've went from this arrow to this arrow. Okay, and we're going to do the same thing at 2. We're going to say 2.next should be 2. And then we're going to say 1, right? 1.next should equal 1. So at the end of all those recursive calls, we're going to have a reverse linked list. Hopefully that made sense to you. If not, then we're going to actually code these two solutions up, and that will probably clear some things up. So let's go through the iterative solution first. Now for the iterative solution, the one thing I kept saying was having a previous variable, right? So let's make sure we get that all set and squared away. So at first previous is none, because we haven't seen any nodes yet. And then we also need to have a current node variable, which is equal to the current head. And then we're just going to walk through this linked list while current node. We're going to say current node dot next equals previous. Very simple here, we're just flipping the arrows. And then after that, we're going to have to save, or rather, before we set the next of the current node, we have to save the next of the current node. So we're going to make a temporary variable that saves the next of the current node, right? And then we want to make sure we update the previous variable because we are continuing to walk through this linked list, right? We have to update the previous. Okay, and then at the very end, we also have to update our current node. And then we just return the previous. We return the previous because once our algorithm reaches a none, right, we can't just return the none, we have to return 5, which is the head of our newly reversed linked list. So that's why we return the previous. Okay, let's see if it works. Great. Okay, so let's go through the recursive solution now. In the recursive solution, one thing that I kept hammering home was the base case. So what is our base case? Well, if you remember, it was whenever we reach the last node in the linked list. So in Python, that would be something like this. There's one more thing I forgot to mention, which is that if the people give you an empty linked list, then you have to account for that too. So something like that. And in either case, you would just return the head. In the first case, you have an empty linked list, the head is empty, so you just return none. And that's the correct answer. And in the second case, where we actually reach 5, or the last node of the linked list, we just return that last node. So same thing for both cases. Okay, now that we have our base cases out of the way, we have to start writing the recursive formulation. Now, in the recursive formulation, what we're going to do is literally traverse this linked list from beginning to end. So we're going to say new head equals reverse list, or rather self.reverse list, head.next. Okay, so eventually we're going to go from 1 to 2 to 3 to 4 to 5, and here we're going to hit our base case. So just keep that in mind. Okay, the next thing we have to do is start flipping some arrows, right? So we're going to say head.next.next equals head. And this should be familiar because we just mentioned it when we were going over the recursive solution. And then you have to be careful because you want to eliminate the original arrow that was there. So for example, if you were trying to flip this arrow, oh, sorry, this is the iterative solution. If you were trying to flip this arrow so that it becomes this arrow, you have to make sure that you erase this original arrow too, which is why we set head.next equal to none. And then at the very end, all you have to do is return the new head. The new head will always be 5, and since 5 is the head of our reverse linked list, that is the thing you should be returning. So let's see if it works. All right. So time complexity of both solutions is linear, but the recursive solution has a linear space complexity, whereas the iterative solution has a constant space complexity. It's one of the drawbacks of the recursive solution. So keep that in mind as you're trying to answer this question for any interviews in the future. All right, well, if you like this video, please like, comment, and subscribe. And in any case, I'll see you in the next one. Thank you.